Welcome, everybody. I'd like to start and end on time. That's the only place in my life that I am on time. So try to maintain a good track record. But I'm Lisa Marshall, the program director for HeatSmart Tompkins, now also serving Chemung County, which is actually where I live. So I'm tuning in today from as my husband says, under the middle finger of the Finger Lakes, right down here in Chemung County. And it's nice to see all of you. We are expecting a bunch more people. So Nina, I made you a co-host, and if you could just keep an eye on the waiting room and make sure you let people in, very much appreciate that. And I am just going to welcome you. Thank you for spending, 45 minutes to an hour with us here tonight out of your busy schedules. I'm going to share my screen and just get started on the presentation. And after a short presentation, I'll introduce our HeatSmart partner installers and take folks' questions. So during the presentation, if you just don't mind staying muted, and please make use of the chat function to ask questions or make comments. And you'll notice that our wonderful clean energy intern, Nina, will also be posting links to related information in the chat, how to enroll, how to find out more on our website, because in a short presentation, I just can't cover everything that you might want to know. So with that said, I'm going to go ahead and share my screen. So once again, I'll just welcome everybody to this webinar with HeatSmart Tompkins. I'm Lisa Marshall, the HeatSmart Tompkins Program Director, and we now serve Tompkins County and Chemung County. We are a community-based nonprofit. We started as just a grassroots community effort here in Tompkins County. And what we like to emphasize in our outreach and education efforts are the cost savings, the comfort and healthy home solutions, and the climate solutions that are all available to you for your own home or building. So HeatSmart is one of the NYSERDA clean heating and cooling communities that are popping up all over New York State. You can see them pictured here. And I'm very thrilled to say that this map needs to be updated. And there are now a few more of these clean heating and cooling communities coming down the pike that have been funded. And also, like HeatSmart at Seago has now expanded to several more counties. And HeatSmart Tompkins has expanded down here to Chemung County, and there's pretty soon going to be HeatSmart coverage in all these areas. So if you're joining us from a different part of the state, or if you have a friend who's interested in a different part of the state, you can direct them to their local clean heating and cooling community program to help get them started. And so the other reason I love to show this slide is that HeatSmart Tompkins was the very first HeatSmart program before NYSERDA got involved. And we just pioneered this idea of doing education and outreach around home energy efficiency, and in particular, heat pump adoption for your home heating and cooling. And we're really proud of the way this idea has grown and flourished here in New York State, and even beyond New York. There's now HeatSmart programs in Massachusetts, and they're in other parts of the country popping up all the time. So we're really proud of being the pioneer program that got this all started. So why do we need such a thing as a clean heating and cooling program, or a HeatSmart program? Well, the reason is because you might have heard about the climate crisis, or some are calling it the climate emergency. And the reason we are having a problem with our climate is because of all the greenhouse gas emissions from burning fossil fuels, mostly, that are going up and up and up each year, and have been, I'm 52. They've been going up every year of my life without any pause. And in order to maintain a livable climate for us and our children, and all of the wonderful diverse species on the planet, we're going to need to do something about this pretty quickly. And so when we look at where those greenhouse gas emissions come from here in New York State, they come from basically three main sectors, which are transportation, on-site combustion, and electricity generation. And this on-site combustion piece of the pie, this what is 38% here, which is a little bit of a fudged number. It's actually a bigger number total than transportation if you calculate it a slightly more honest way. So a lot of that on-site combustion is home heating. And that's because 90% of our households in New York use fossil fuels to heat our homes. So each of us, 90% of us have a furnace or a boiler churning away, eating up fossil fuels to produce heat. And that is why HeatSmart exists, is to help educate people and make it easier for people to adopt alternatives to that current scenario. So how do we do that? Well, that's a pretty daunting question. And the main way we are going to reduce our greenhouse gas emissions in these sectors, transportation and home and on-site combustion, is something that is been termed beneficial electrification. So if we electrify our cars and if we electrify our heating, we can immediately have more efficient heating and transportation in our homes and for our cars with the current way that we generate electricity. And then as we add more and more renewables to the electricity grid, those methods of transportation and heating become even more efficient. So this is a great graph from the Acadia Center that just shows, this top is what most of us have now, is a fossil fuel car and a fossil fuel burning heating system in our house. And this is how many, million metric tons that of CO2 are produced by that. And down below, you can see that drops down significantly if you switch that to electricity. And this what it says current RPS that's with the way we produce our electricity now. And then as we increase the renewables, so more wind, more solar on the grid, then these become even more efficient and we're emitting less carbon dioxide. So in a simplified way, that's what beneficial electrification is all about. So how do we, more specifically, because this webinar is steps to a fossil-free home, how are we using energy in our homes? This is not for New York. The next slide will show you New York more specifically, but I liked this slide because of the cute little house. And this is sort of an average house in the US, how they use electricity. So 55% of that, not how we use electricity, how we use energy, excuse me. 55% of our energy use in our homes is heating and air conditioning, and most of that is heating. Only a very small sliver is air conditioning. 15% is running our appliances, 15% is hot water heating, 10% is lighting, and 5% is electronics. So the cell phone, the computer, the TV, etc. And that is the sort of an average breakdown. Of course, your mileage may vary. This next slide shows you a little bit more closely how we're using energy in our homes here in New York. So on the right-hand side, it's showing New York compared to the average mid-Atlantic states region and the whole US. And as you can see, heating for us is space heating. This pink part is 56% of how we're using energy in our homes. It's just huge because we live in this cold climate, and only 1% in New York is air conditioning. Although this is a little bit of an older graph, I think it's from 2012. So that may have shifted somewhat in the intervening years, but generally speaking, it's about right. And then I want you to notice this 17%, this orange pie piece for water heating, because we're going to talk about that as one of the steps to a fossil-free home. And then 26% appliances, electronics, and lighting. And I'm not really going to talk about lighting, but I'll do a shout out right now. If you haven't ever worked with the energy navigators to have a look at your own house, they are a great group. They're volunteers who are trained as energy navigators, and they will come to your house and help you look at things very specifically, like your lighting. And basically, if you're not using LED light bulbs yet, then get on it, because it's by far the longest lasting and most efficient light bulbs. And that's all I'm going to say about light bulbs. Okay. So 56% of the energy in New York households is for space heating, and 17% for hot water. So what are these steps that we're talking about? Step one is the building envelope. So that is how well insulated and sealed is your house. And as you can see on the right here, this is how heat energy escapes from your house. All these different places, and the most is the floors, walls, and ceilings, but also the ducts, the fireplace, the plumbing, doors, windows, fans, vents, and electrical outlets. I just want to point out that Windows is 10% on average in this graphic. And so a lot of people will say, well, the first thing you should do is replace your windows. And I don't think that's the first thing you should do. I personally preserve the beautiful antique wood windows in my house and try to seal up other things first. Windows are a big piece, but they aren't sort of as big as most people think. So in the average home, the air leakage is squandering 15 to 25% of the heat that you're producing. So the first step to a fossil-free home is to just make sure you're not literally throwing that heat out the window, so that you're burning less fossil fuels to heat your house while you're still using those. And that the same amount of unwanted heat is coming into our houses in the summer equivalently. So that's not good. It's about the same as if you had a completely sealed house, but you left one window wide open in your home all winter long. None of us would do that. Of course, that's a horrifying thought, but that's actually what we're all doing. In fact, if we haven't taken care to seal up our house properly. So the order of operations for insulation and air sealing is sometimes people talk about the ABCs. If you don't know where to start, remember the ABCs. A is for attic, B is for basement, and C is for the conditioned space. So that's if you can't afford to get your whole house done all at once, that's the order that you want to go in for the maximum benefit. Okay, so that's step one, is just make sure your heat isn't going out the window. Step two, that big chunk, is space heating. And that's what HeatSmart Tompkins is all about, is promoting air source or ground source heat pumps for space heating. On the left, you have a picture of an outside unit of an air source heat pump. It's not the prettiest thing in the world, but it's a great little machine that keeps your house warm in the winter and cool in the summer. And on the right, this graphic is showing some ground coils for a ground source heat pump system. I'm going to talk a little bit more about those. They're going to get top billing in this webinar. So what is a heat pump? If you're not familiar with heat pumps at all, you might be confused about them. Actually, all of you have a heat pump in your home. That's what runs your refrigerator. You might have noticed that there's a refrigeration loop on the back of your refrigerator that keeps the inside of your refrigerator cool. And you might have put your hand behind a refrigerator and felt that it was very warm out there. That's because of the way the refrigeration loop works. So inside that loop is a chemical called a refrigerant. And the loop works on the principles of physics. So when you condense the refrigerant, you get heat out because there's a phase change in the refrigerant. And when you expand it, you get heat in when you evaporate that refrigerant. So it's sort of a genius thing, because it is just this incredibly efficient way to take heat out of the air or out of the ground and put it through this refrigeration cycle that allows you to use that heat to air condition or heat your house. So ground source heat pumps basically have three main components. There's the loop field, which is shown here on the right. That's a horizontal loop field. There can also be a vertical loop field where you dig vertical boreholes and put the loops down in those, or you can put loops, heat exchange loops in a body of water sometimes. So those collect the heat from the ground and bring it into your house. And then it goes into the heat pump itself, which is this little guy on the left. And it looks kind of big in that picture, but it's really about the size of a refrigerator, maybe a little bit bigger than your existing furnace or boiler, but it's not enormous. And that's where the refrigerant loop takes that heat from the ground and puts it through the condensation process and puts the heat out into your house through your distribution system, which is the third part. So in this one, we're seeing a forced air distribution system, which is these ducts that take the hot air and distribute it throughout the house. We also have air source heat pumps. A very popular kind of air source heat pump is the ductless mini split. It's very popular because it's incredibly versatile. You can sort of put one of these almost anywhere that you need some heating or some air conditioning. In fact, a lot of people in this area have ductless mini splits for air conditioning, and they don't even know that they could be used for heating, which is really unfortunate because they spend a lot of money on an air conditioning system that if they had invested in one that was a good, efficient cold climate ductless mini split, they could use it for their heating as well. And these are taking the heat energy from the outside air and putting it through a refrigerant loop and bringing that is connected from this outside compressor, and then sending it inside to these inside heads that are pictured either this here, or you can see the drawing here. Those are high wall mounted heads. You can also get low wall mounted heads that look more like a traditional radiator. And something that's really important to understand about these air source heat pumps is that a lot of people think that they don't really work in cold climates like ours. And that did used to be true, and it's not true anymore. There's fantastic progress been made in the technology for these air source heat pumps, and they work great. I was in Norway last year, and everyone there has an air source heat pump. And Norway's colder than Ithaca, so this is a very good heating system now for cold climates. They are guaranteed to operate down to negative 13, and they still function down to negative 19. And these are, because the outside air is quite a bit colder than the ground, their efficiencies are not quite as good as a ground source heat pump, but still they can be up to 250% efficient, which is really great. Definitely a lot more efficient than any kind of fossil fuel burning you might be doing in your house. And just want to let you know, in terms of heat pumps, how inexpensive they are to operate as compared to the fossil fuel options that many of us are using in our homes, and even compared to pellet stoves. Ground source heat pumps are the absolute cheapest kind of heating to operate in, except for a wood stove. And they also are much more efficient and provide air conditioning as well. And air source heat pumps are a close second. So as you can see, a lot of people are still heating with propane, and by putting in any kind of heat pump system to replace your propane, you're going to be cutting your bills at least in half, but often much, much more as compared to propane, and also much more efficient than any kind of electric baseboard heating. So if you are heating with propane, there's just as somebody just said yesterday on Facebook, I thought I couldn't afford heat pumps, and then I realized I couldn't afford not to have heat pumps. So I'm going to keep that in mind. I'm not going to talk too much about the incentives, but just to say there are incentives available to help make the upfront cost of heat pump installation more affordable. These are the incentives through NYSEG or whatever your local utility is. They could be different for different utilities, but in this service area, we have NYSEG, and this is what they offer is $1,500 off per 10,000 BTU hours of heating load for ground source, and $1,000 off of 10,000 BTU hours of heating load for air source. And since most of us have no idea what that means, I can just tell you a typical rebate for ground source is going to be close to $4,000 to $9,000 off the top of installing such a system, and $2,500 to $6,000 off the price of an air source heat pump, depending on the heating load that you need for your house. For the rest of this year, there's also a 26% federal tax credit for ground source heat pumps, and a measly $300 Energy Star tax credit for air source heat pumps. But hey, it's, $300 is still $300. So next year, that federal tax credit for ground source heat pumps goes to 22%, unless something changes at the federal level. And there are a lot more incentives to help folks pay for these heating systems if you are income qualified. We've just done a couple of webinars on that. You can find them on our website, or you can get in touch with me to find out more. And if you're heating, again, with propane, oil, or electric resistance heat, there's going to be a heat pump pilot to help people who are income qualified convert to heat pumps who are heating with those fuels. So please get in touch with me if you're interested in that, because it's going to be a really great, but also very short-term opportunity available to you. And that's all I'm going to say about that tonight, but feel free to ask questions about that later, or make an appointment to talk to me. Okay, so step 3. Step 1 was your envelope. Step 2 is your heating system, and step 3 is your hot water. So what we recommend here at HeatSmart is a heat pump water heater. They are so again, there are different numbers: 15% of your home's energy use, 17%. This slide says 23%. I can't remember where I got that number from, but it's probably about 20% for most of you. These heat pump water heaters are up to 3 times more efficient than the water heater that you're using now. They have very low operating costs because they're heat pumps. And you have to pay a little attention to where you put these, because they are this little top unit on here, or also this one that sits on top of the water heater, is a heat pump. So it's taking heat out of the air. So you don't want it in your living space that you're trying to keep warm. That's sort of counterproductive. And you want it to be in a basement space. That's best. Also, they're a little taller than a conventional water heater. So if you don't have a tall enough basement, that might not work for you. But if you can, this is what we highly recommend here at HeatSmart. And we're really thrilled that NYSEG came out with a $700 rebate for these guys. There didn't used to be any rebate, and now there's a $700. And there's, again, for the rest of this year, a $300 Energy Star federal tax credit that you can apply for. So, that's $1,000 off the price. So there's really no reason to not put in one of these water heaters if you are looking for a new water heater. I should have said at the beginning, the order of the steps might be different for each homeowner, and we can talk about that later. I put them in order of sort of how I prioritize them in my head, but step 1 for you might be the water heater and not the building envelope. So I just want to throw that out there. Okay, so that's step 3. Step 4, cooking. I find that a lot of people are ready to give up fossil fuel heating, but they're not ready to give up fossil fuel cooking because they say, well, good chefs cook on gas. That's because they haven't met the wonderful induction cooktop or stove. They are much more efficient. They are cleaner. They are safer. And they're cooler. In other words, they're not going to heat up your kitchen in the middle of summer because you're not going to have an open flame there. And so induction cooktops work with basically like a magnet that connects to your pot or pan, and that magnetic connection is what creates the heat. So they are, the food that's being cooked gets 90% of the heat that's generated, as opposed to when you're burning gas, 40 or 55% of the heat that's generated goes actually to the food. So the rest is heating up your pot, heating up your kitchen. And top chefs all over the world really recommend induction cooking. Everywhere in Europe that you go has an induction cooktop. And these days, the snazzy fancy thing to have in a gourmet kitchen is a snazzy fancy induction cooktop. Not gas is past, and this is the way to go. I'll just add one more thing about this, which is that the Rocky Mountain Institute has been doing a ton of research on indoor air quality from fossil fuel combustion, and they've looked at cooking over gas, and the health impacts and air quality impacts of cooking on gas are actually quite a bit worse than most people thought. And if you are still cooking with gas, make sure you're always venting to the outside, and don't let children cook on a gas stove because it's actually pretty harmful. So one more thing about induction cooking: if you aren't ready to replace your stove quite yet, and maybe you're waiting to do a kitchen remodel, or maybe we're waiting to get a heat pump, or whatever you're waiting for, you can get for about $50 a 1-burner induction cooktop that just plugs in like a portable one from IKEA, from Aldi, or from several other places. And that's what I have because I haven't replaced my gas stove yet. And so if I'm only needing 1 burner, or if it's really hot in my kitchen, I just use the single burner one on my countertop instead of turning my stove on. So that's a great interim measure if you're not ready to replace your stove yet. So we're almost done. So step 5 is go solar or go renewable. So how is that electricity that you're using in your house? Are you just getting whatever NYSEG is delivering to you, or are you going to do one better? There's 3 ways to go solar for your electricity. One is a community solar farm, and that's the one that I would sort of most recommend right now. And there's 2 ways to become involved with the community solar farm. You can subscribe, or you can purchase the solar panels. So you actually own them. So this is not at your house. This is in a field somewhere nearby, and you will automatically right now save money if you join one of these solar farms compared to what you pay NYSEG for dirtier power. So there's really no downside to the community solar farm that I know of. Then, of course, there's rooftop solar. That's what I have at my house. And I think it's really great. And I love the bragging rights of having the rooftop solar. The problem for me is I did the steps out of order. So I got solar, then I got an electric hybrid car, then I got an all electric car, and now I'm going to get heat pumps. So my solar panel array isn't big enough to power all of the electricity needs in my house. And because you're only allowed to net meter in one place, I can't buy into a community solar farm because I have solar panels on my roof. So I think it's great if you want to have solar panels at your own house, but that's one reason I would definitely recommend the solar farm. By the way, though, at least 2 of our installers, our heat pump installer partners, Halco and Daily, do solar panel installation. So if you're interested in rooftop solar, you can talk to them about that. And the third option is that can be combined with these other 2 is buying into or signing up for a renewable ESCO, an energy subscription. So I'm signed up with Energy Co-op of America, and so I'm buying my power technically from them instead of from NYSEG, although NYSEG still does the delivery and charges me for the delivery. So that's how I assuage my conscience for the smaller than I need rooftop solar array, is I also have this renewable ESCO on the side. But do be careful about ESCOs because they can be kind of shady. And Jerry Wiley, who's a volunteer with HeatSmart Tompkins, keeps a close eye on them and publishes a monthly report on ESCOs. So go to the HeatSmart Tompkins website if you are interested in learning more about the different choices in ESCOs that are out there. So those are the 5 steps. We'll review what they are. They are building envelope, they are heating, they are hot water, cooking, and solar. As I said, what order is right for you? It might not be the order that I put them in. And if you can afford to do it, you could do all 5 at once. If you can't afford to, then really working with HeatSmart and with our installers, we can help you sort of advise you how to do which thing when. And if you're silly like me and you did solar first and the other things afterwards, that's okay too. We're all just doing it as best we can. I'll just quickly say, in the time of COVID, we no longer go out in the community and do our community meetings. We have these webinars instead. And we invite you to join as many as you like. If you miss one or it's an inconvenient time, we do put the recordings up on our website afterwards, so look for those. We are doing a really great series of home tours of HeatSmart homes in the area. A lot of people that have implemented some or all of these 5 solutions into their homes already, so you can meet the homeowner, meet the installer that put it in, and talk to them, ask questions. And again, we put those up on our website when they're done. And we've also added a lot of information to our website. We have fact sheets, we have all kinds of, we can read about all the different installers, you can read more about these technologies. So please make use of that website. And we hope that you will enroll with HeatSmart. And when you do, that means that you're asking for our installer partners to give you a proposal for your home. And just to reassure you, if you're not comfortable with people coming into your home at this time during COVID, our installers can do remote assessments. So you can just ask them to do that. And they have developed really great techniques to assess what you need in your home without stepping foot across the doorway. And if you do invite them to come to your home, they've also put into place very careful protocols to keep their employees and all of you safe. So I really trust them to be doing that every day. So the way to get started is to enroll on our website, heatsmarttompkins.org. If you're joining us from one of the other HeatSmart communities, they also have websites. I'll show you their contact information. Home assessments are free. You can get 1, 2, 3, or all 4 of our installer partners to give you an assessment. There's no obligation whatsoever to you for taking part in the program. And I'm here at any stage of the journey, whether you're just first thinking about making changes in your home, or whether you've been thinking about it for a while and you're ready to sign a contract, or whether you've signed a contract but you still have questions. I'm here as a resource for you to sort of help you along the way. I'm just going to show you this slide. If you are not in the HeatSmart Tompkins area and you want to contact one of the other HeatSmart programs, you might want to take a screenshot of this slide, or I'm also happy to send you this information if you're in one of these other neighboring HeatSmart program territories. We work very collaboratively and closely together, and we're happy to help you find the HeatSmart home for you. And with that, I just want to introduce you now to our HeatSmart installer partners. These 4 companies have gone through a very rigorous application and vetting process with our program to be a part of it. They are the companies locally that we think provide the best equipment, best design, best customer service, have the best track records, and are just a pleasure to work with. We recommend all 4 of these companies. Each of them offers something slightly different. And Daily Geothermal and NP Environmental are heat pump specialists. And Halco and Snug Planet are whole home contractors doing a lot of insulation, air sealing, and as well as heat pump installations. So that's it for me. I am going to stop sharing my screen and stop talking for a minute. And thank you for sitting through that. And I now want to welcome our installer partners to introduce themselves and then take your questions.